Sorry about the cutoff there. 15 minutes is max. So we can see background radiation. And then if we turn those satellites inwards, we can actually see that like China's been putting polluting, ozone depleting gases into our atmosphere, even when the whole world has agreed that we're not supposed to be doing that. So then we're looking now at like how the sun and the moon and the earth all interact. And this is like a really big topic and it'll be spread over a little bit. But we used to think that earth was the center of the universe, right? Everything revolved around us, kind of like we think now in a personal day-to-day life. But we know better, and we know that the sun is in the middle of the universe because it's so big. And not the universe, sorry, but our solar system because it's so big. And there's other suns out there too. And everything in our solar system revolves around the sun in an orbit. So early universe, we know started from those satellites. We know started condensed into a tiny little bubble. And Edwin Hubble, who launched the Hubble Space Telescope, which is about the same size as a shipping container, he launched his satellite, or we launched that satellite, and by looking at the radiation that's left over from the Big Bang, even the radiation got pushed out. So from those observations, we see that there's a big bubble. And so we can track back that 13.7 billion years to see that like everything started in one spot. And so all the galaxies have been pushed out from that spot, and they're still going out. They're still getting further apart from each other. Now, galaxies is something that obviously you're going to come across lots when you're thinking about space. It's something that we've seen pictures of. Those first pictures that I showed you at the very beginning of the first PowerPoint lesson was actually galaxies. And really, like, our sun is only one of 100 million stars in the Milky Way, right? There's 12 or 125 billion galaxies in the whole universe, right? And they all have varying numbers of stars, but we're just one of those stars that has one set of planets around it. So there's all these planets out there, and that just gets exciting for when you think of what possibilities that can come up with. Now, we're going to look at really quickly how the universe changes over time, and that actually goes into stars, right? So there's this video that you guys can look up. It's called The Star is Born, but it's a parody. So there's you can either click on this one or just look for this one here. It's an ASAP Science video. It uses the song from A Star is Born. It's like, what would happen literally if a star was born? So it actually does a better job of explaining what it is that I'm about to explain. So you might want to go take a look at that afterwards as well. So stars are huge, and they're mainly gas, right? They're just a very, 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 very dense ball of gas, hydrogen gas, that when two hydrogens come together, they fuse. And remember fusion energy from physics. They fuse together, they make helium, they release a ton of energy, and then that goes out into the universe. It starts generally with a nebula. And so a nebula is just a big gas, a massive gas that's going around itself. And then it condenses in and becomes solid. Well, not solid, but like becomes so dense that we start to get a reaction that starts to take place. There are like varying differences of sizes of stars. And so this picture is actually showing one star eating another star, which is actually kind of fun. And this Hertzsprung-Russell diagram actually shows the varying densities and sizes and light, like how much light's given off, the temperature that the stars are, how bright it is. And generally, we all end up with stars in the main sequence there, and they're red. They're red giants. By looking at the star's color and all of those characteristics, we can actually see that we can tell what is actually the stars are made up of. And so depending on what color they are, we can learn different things. Our sun, to bring it back home, contains 99% of all the mass found in our solar system. So you think about all the planets and how big they are. You think about Earth and how big it is. It's not even close, right? 99 times the mass of our whole solar system, or 99% is stored in the sun. The Earth, and to give you a perspective of how big the sun is, right? You would take 110 Earths just across to fit that distance, and even that is hard to fathom, right? If you picture a basketball and you put 110 anythings across the middle, that is an okay comparison. Just picturing how small we would actually have to be. So solar wind is something that is ejected from the sun. It's what happens when the inside of the sun kind of shoots out a gust of energy. And these gusts of energy, when they hit our magnetic field and go through our atmosphere, actually give us this thing called the aurora borealis. Now, the thing with the aurora is that, to bring it back to where we started the first video, is that we actually have across North America so many different Aboriginal groups that have actually come up with very similar stories to this phenomena that they saw in their past. But all of the stories are very similar, which is really an interesting thing when you go and think about how these stories come to be. So it's actually Spider-Man that protects us in our universe, and that's a joke, obviously, because it is the Earth's magnetic field, and this graphical representation just shows it just looks so much like Spider-Man. So what it does, though, is it actually blocks a lot of the radiation and a lot of the damaging things that would kill us just by being there. And so that protects some of our satellites, but sometimes those satellites do get damaged, and they either become non-operational. It can wreck things on Earth. It can cause problems for us here, even with power plants. And so that's it. So we're done with the first video. I'm going to post the second video as well, and I'll record that shortly. But yeah, hope you guys are doing great, and we'll talk soon. Okay, bye.